Okay, on this example, we're given an equation in two variables with x's and y's. We're given this information that y of 16 equals 16. And I understand that notation is a little bit weird. All right, basically this means if you have 16 plugged into the function, like y is the function name, you're also going to get out 16. So basically we have an x value and a y value given to us that correspond. And that kind of makes sense if you look over at our equation. If you replaced x with 16, square root of 16 is going to be 4. Replace y with 16, square root of 16, again 4. 4 plus 4 makes 8. All right, our end goal on this, though, is to find y prime of 16 by using implicit differentiation. So let's jump right in. We'll come back to that 16, 16 as an ordered pair. Shouldn't be too bad as long as we understand how to rewrite this. I think rewriting this really helps out a bunch. Instead of seeing square roots, what we'd like to do as we're doing derivatives is use the power rule as much as possible. So we want to rewrite this instead of the square root of x, we can say x to the 1/2 power. Square root of y can become y to the 1/2 power. And then for the time being, we'll leave 8 alone on the right-hand side. So just to be clear, at this point, we haven't taken any derivatives. We've just rewritten the original problem so that we can see it as our variable raised to a power. All right, next comes the taken derivative part. So implicit differentiation, we'll kind of work this one term at a time. On the first term, we have x to the 1/2 power. Well, like I said, we can use the power rule in this case, bring the exponent down in front, and then reduce the exponent by 1. So we want 1/2 minus 1 is going to get us to negative 1/2 for our new exponent. Now, because our variable was x in this case, taking the derivative, we don't put a y prime next to it. However, on that next term, it's kind of the same work as far as taking the derivative. Exponent comes down, reduce the exponent by 1, so 1/2 minus 1 makes negative 1/2. But this time, because our variable was y, we are going to include multiplied by y prime hanging out next to that. On the right-hand side, the derivative of a constant of 8 in this case is going to work out to be 0. All right, so from here, what we'd kind of like to do is I typically try to get the y prime on one side all by itself. But noticing those negative exponents that we currently have, let's think about rewriting these so we don't have negative exponents. All right, so to eliminate a negative exponent, what we can do is we can move that down to the denominator and make it positive. It also works in the opposite direction. If you had a negative exponent that happened to be in the denominator, you can move it up to the numerator and make it positive. All right, so we got rid of the x to the negative 1/2 by moving x to the positive 1/2 down to the denominator. And then on this next one, we can say, well, this is 1 over 2y to the positive 1/2. And it's kind of up to us whether we want to include the y prime off to the side, or you can also put that up in the numerator if you'd rather. All right, next what I'm going to suggest is let's go ahead and work on isolating that y prime further. So to do so, I'm going to first go ahead and suggest let's move the first term that has the x over to the right-hand side. So I'm going to go ahead and subtract 1 over 2x to the 1/2 power from both sides. All right, by subtracting it, it'll eliminate it from the left-hand side. So what we're going to be left with is going to be y prime over 2y to the positive 1/2 power equals negative 1 over 2x to the positive 1/2 power. All right, next, we still need to get y prime all by itself. So we need to get rid of that denominator, basically, from the left-hand side. So to do so, I'm going to go ahead and suggest that we multiply both sides by 2y to the 1/2 power. In doing so, multiplying and dividing by the same thing gives you the same thing like numerator and denominator and makes a 1. So that'll get y prime on the left-hand side all by itself. We can do a little bit of reducing down on the right-hand side. This will work out to be negative, as we think of this as over 1, multiply numerators together, 2y to the 1/2 power, multiply denominators together, 2x to the 1/2 power. From here, we may notice we have a 2 numerator and denominator, making a 1. And we could rewrite this if we wanted to. Instead of y to the 1/2 power, remember the square root of y means the same thing as that. Same thing in the denominator, the x to the 1/2 power means the square root of x. All right, from here we now have the derivative y prime, but we are specifically asked, if we go back up here to the beginning, we are asked to find y prime of 16. All right, so this goes back to, remember, x value of 16 goes with a y value of 16. So we're going to take our derivative and we're going to replace the x with 16 and also, in our case, the y with 16. All right, so to finish this up, we're going to get the negative of 16 went in for y, 16 went in for x. Little reducing down, we're going to get the negative of 4 over 4, which turns out being just negative 1. So our final answer as we look at this is going to be, sure enough, negative 1 is going to be our derivative. When we plugged in 16 for our x, also corresponds with the 16 for our y. So I hope this helps out as you're working through problems like this, trying to figure out implicit differentiation. It mostly just takes some practice, but you'll get the hang of it. Good luck.